Imagine that your management asks you to set up 3-node development cluster within your company's infrastructure. In this scenario, how do you install and configure Kubernetes cluster? Hello and welcome to kubeadm. So in next few minutes, I'll try my best to get you up to speed on what is kubeadm and how to install and configure Kubernetes cluster using kubeadm. But before you watch this video, it is required to have a basic understanding of what is Kubernetes and its basic architecture. So without any further delay, let's take a look at the things you'll be learning in this video. This presentation is divided into two sections. In first section, we'll discuss the concept around kubeadm. First, what is kubeadm and what it does. Then, we'll discuss about the commands related to kubeadm. So that's about the section 1. After that, we will review the demo we are about to perform on a live system. This will help you better understand when you watch actually doing it live. In this review demo, I'll show you what are the prerequisites required before you install Kubernetes. Then, we'll install the software applications related to Kubernetes. After that, we will configure the Kubernetes master node. Then, we will configure the Kubernetes worker nodes and join the worker nodes to the cluster. And finally, we'll test and validate entire setup. So that's about the section 2. In case if you are looking for a live demo on installing Kubernetes on kubeadm on the system, then please do check the links in the description below. And now, let's get started with what is kubeadm and what it does. First, let's discuss about what is kubeadm. Kubeadm is a command line utility which will help you to bootstrap your Kubernetes cluster that conforms to the best practices. So before kubeadm, things were very complex and time-consuming to configure Kubernetes cluster. So if you are just curious how hard it is, then just Google Kubernetes the hard way. The results will show you the Kesley Hightowers how to guide in configuring Kubernetes hard way. But luckily, with the help of kubeadm, all that complexity was hidden and made it a lot easy for newcomers to configure Kubernetes cluster. If you are new to Kubernetes, then you can start with kubeadm to try Kubernetes, and which will make your life much better. If you are someone who are already familiar with Kubernetes, then you can spin up the cluster with kubeadm and test their applications. So now, let's see what are some of the operations that you can perform with kubeadm in next slide. In this slide, we'll go through some of the kubeadm commands. First command is kubeadm init. Kubeadm init will initialize the Kubernetes master node. So run this command whenever you want to configure any node as master node. After kubeadm init, next thing we are going to look at is kubeadm join command. So kubeadm join will initialize the worker node. So run this command whenever you want to configure any node as worker node inside the cluster. Let's review it again. We have a kubeadm init to initialize the master node, and we have a kubeadm join command to initialize the worker node. So these are the two most frequently used commands when it comes to the kubeadm. So there are few other commands that you might want to be familiar with. At a high level, kubeadm token command. This command will help you create tokens. Next comes the kubeadm version. As its name implies, kubeadm version prints the version of kubeadm. And final command here in this list is kubeadm upgrade. Kubeadm upgrade is a user-friendly command that wraps complex upgrading logic behind one command. So with the help of kubeadm upgrade, we can upgrade the Kubernetes and also we can downgrade the cluster if necessary. So these are some of the commands related to kubeadm, and there are some more available on the website. Overall, kubeadm init and kubeadm join are the two commands that you might want to focus extra on this one. Overall, you might want to more focus on kubeadm join and kubeadm init in this video. So with that, let's move on to the next slide. Before we get into the details, I just want to quickly show you how Kubernetes architecture will look like and what are the components Kubernetes master and the worker node has. As you can see, Kubernetes master consists of API server, scheduler, etcd, and control manager. Here, API server is kind of a gatekeeper for the entire cluster. If you want to create, update, delete, or even display any Kubernetes object, it has to go through API server. Next, scheduler. It is responsible for physically scheduling pods across the nodes inside the cluster. Next, controller. Controller is responsible for overall health of entire cluster. It ensures nodes are up and running and correct number of pods are running as mentioned in the spec file. And finally, etcd. etcd is going to be the Kubernetes central database to store entire Kubernetes configuration, including objects it is creating, secrets, and more. It is a key value database. Any component of Kubernetes can query etcd to understand the state of the cluster in real time. And now, moving on to the node components. In Kubernetes worker node, we have 4 more important components, and they are kubelet, kubeproxy, pod, and containers. First, we have kubelet. It is a primary node agent that runs on each worker node inside a cluster. It looks at the pod spec that was submitted to the API server on Kubernetes master and ensures that the containers are described in the pod specs are running and healthy. In case if kubelet notices any failures with the pods running on this worker node, then it tries to restart the pod on same node. Next, kubeproxy. Kubeproxy is a critical element inside Kubernetes cluster. It is responsible for maintaining the entire network configuration. It essentially maintains the distributed network across all the nodes, all the pods, and across all containers, and it also exposes services to the outside world on the internet. Next comes the pod. Pod is basically a scheduling unit in Kubernetes, just like VM in VMware world. So each pod consists of one or more containers. In most cases, there will be one container. So the primary advantage of pod is we can deploy multiple dependent containers together. So it acts as a wrapper around these containers. Finally comes the container. It provides a runtime environment for your applications. So you run containerized application processes inside these containers. So that's about the Kubernetes important basic components. Now we'll look at the process of creating Kubernetes master and the worker nodes. Finally, at the end, we'll deploy a sample application to make sure everything is working as expected. Now, it's time to go through some of the steps involved in creating Kubernetes cluster with master and node. This is primarily divided into 2 subparts, that is, installing and testing. So before we go ahead with installation steps, let's review the prerequisites for setting up Kubernetes cluster using kubeadm. So coming to the prerequisites, first thing, make sure the VMs that you are creating as part of this setup has at least 3 GB RAM and 3 virtual CPUs. These numbers are based on my experience. You might see these numbers bit less on official documentation. And next requirement is to have a full network connectivity among all machines in the cluster between the master and the Kubernetes worker nodes. Next is to disable swap on all nodes. And the final requirement here is to disable SELinux. You have to do this until SELinux support is improved in kubelet. Now, let's take a look at the steps involved in creating Kubernetes cluster in next slide. In this slide, we'll discuss about the 6 steps involved in creating Kubernetes cluster. So in the first step, we'll create the VM which are part of Kubernetes cluster. In next slide, I'll show you how many VMs we'll be creating as part of this Kubernetes cluster. Then, we'll disable SELinux and swap on all nodes. After that, we will install the 4 packages. They are kubeadm, kubelet, kubectl, and Docker on all nodes, including Kubernetes master and the worker nodes. And the point to note here is, kubeadm will not install or manage kubelet or kubectl for you. You have to manually do that. So once the installation is done, then make sure to start and enable Docker and kubelet services on all the nodes. Then the fourth step is to initialize the master node. So during this process, all the required components will get installed and configured on the Kubernetes. So during this process, all the required components will be installed and configured on the master server. So can you guess what is a command to configure Kubernetes master node? If your answer is kubeadm init, then it is right. So we will initialize the master node with kubeadm init. And once you configure the Kubernetes master node, and before you join Kubernetes worker nodes, and there is one more step, and that is configuring pod networks, where all pods can communicate with each other across all the nodes inside the cluster. So there are various network plugins to configure pod network. And some of the network plugins we can use are Wave, Flannel, and Calico. In our example, we'll install the Flannel here. Once that is done, the final 6th step is to join the worker nodes to the master node. Then we are all set to launch our applications on the Kubernetes environment. So, before we move on to the next slide, you might want to pause this video and observe these 6 steps again. These are the exact 6 steps that we are going to perform in this video. I believe you are good with it. And let's move on to the next slide. This is how our setup will look like. As you can see, we'll create 4 CentOS VMs with minimum of 3 CPUs and 3 GB of RAM. And for master node, maybe you might want to have a bit higher configuration. In our example, I have created all these 4 VM instances on Google Cloud. In that, one VM will be configured as master node and other 3 will be configured as Kubernetes worker nodes. So that's about the setup will look like. Now, let me show you the 4 VMs I have created inside Google Cloud. So here is a snapshot of 4 Google Cloud VM instances. So creating this VM is very simple. I'm guessing most of us are familiar with it. In case if not, don't worry. I have that covered in the demo. As you can see, all 4 VMs has internal and external IPs. You can log into the server by clicking on the drop-down next to SSH. Personally, I prefer connecting using Cloud Shell to connect to these VMs. Once you have the VMs created, then next step is to disable swap and SELinux, which is step 2. In this slide, we'll first disable swap, then SELinux on all nodes, and finally we'll reboot the VMs to make sure it comes clean. So to disable swap, we'll use the swap off command with the -a option. Also, check there is no swap related entries in FS tab. If there are, please do remove or comment it out. And one of the main reasons why we need to disable swap is the performance related. Next thing is disable SELinux. You can do that by using setenforce 0 command. For SELinux to disable permanently, you need to update config in SELinux config file as shown above. So you have to disable SELinux until SELinux support is improved in the kubelet. You need to disable SELinux and swap on all nodes including Kubernetes master and worker nodes. Once that is done, it is good to reboot all the nodes to make sure it comes up clean. And make sure swap and SELinux are disabled post reboot. So that's about the swap and SELinux. Next comes the installing Docker. Kubernetes supports multiple container engines such as Docker and Rocket. Since a Docker is most popular and widely used container engines across, so we'll go with installing Docker. If you are using CentOS VM on Google Cloud, then please go ahead and install Docker using yum install, as you see in the screen. In case if you are using Ubuntu, you need to use apt-get command instead of yum. You can find those commands on Kubernetes documentation or just Google for installing kubeadm. After successful installation of Docker, start the Docker service and enable the service to start at boot time. We need the Docker container engine on all servers, including master and the worker nodes. So you need to install the Docker and then start and enable Docker service on all servers. Once that is done, then we can install other three applications, which are kubeadm, kubelet, and kubectl. I guess you are already familiar with what this software application does. But just a quick review if you forgot this. First, kubeadm. It is responsible for bootstrapping the Kubernetes cluster. Next, kubelet. This component runs on all machines inside your cluster and does things like starting pods and containers. Finally, kubectl. And this is a command line utility through which we can manage the cluster, such as creating, deleting, displaying, and updating various Kubernetes objects. So all these packages are not available in default OS repository. So we need to create one repo file inside repos directory. This repo file consists of a location where all above 3 Kubernetes related packages are available. Once you have the repo file in place, then you can start installing all 3 packages using yum install on CentOS and then start and enable kubelet service. You need to perform this on all VMs including Kubernetes master and the worker nodes. In case if you are setting up Kubernetes on RHEL and CentOS, then there is one more extra step need to perform, and that is this. This is used for fixing issues where traffic is being routed incorrect due to IP tables being bypassed. So go ahead and update config as you see on the screen. Once you're done with it, now let's move on to the next step where we will initialize Kubernetes cluster. Configuring Kubernetes master node is very simple. It is just one simple command. We can do that by kubeadm init command as you see on the screen. I guess you might be wondering what is that pod network thing here. This is required if you wish to use Flannel pod network add-on. If you ignore this, then kubedns pod will not start. We'll talk about this pod network in next slide. For now, use the exact command to set up the Kubernetes master node. So upon successful execution, we should see something output which is similar to this. In the command output, you will see 2 things. First, we need to execute these 3 commands as a regular user in order to start using kubectl command. Second, it will print join command. You need this command to execute on worker nodes to join them to the cluster. We need this for the future purpose. For now, you need to save it at some secure place. You will see me using this command in a second. So that's all with initializing the node as a master node. Now moving on to the next slide where we talk about configuring pod network on master node. It is required to install a pod network plugin after you initialize the master node. So it will help the pods to communicate with each other. It is necessary to do this before you try to deploy any applications on your cluster and before kubeadm starts up. And there are different types of network plugins as we discussed previously. In this case, we are using Flannel Network plugin. If you remember, we have used pod network CIDR to the kubeadm init command in the previous slide. That's because it is required if you are using Flannel Network add-on. So you can install pod network using kubectl apply command followed by kubeflannel YAML file as you see on the screen. So to confirm if pod network is installed, you can do that by checking kubeadm's pod is running by using kubectl get command. That's about the pod network. Now the final last sixth step, and that is joining worker nodes to the cluster. It is very simple. So to join the worker nodes to the cluster, we need the join command we noted down from kubeadm init command output in previous slide. Here is a join command that was provided to us during initializing the master node. So just execute this exact command on worker node to join to the cluster. So upon successful execution, node will join the cluster. It is that simple. And the token in join command expires after 24 hours. In that case, you can create new tokens by using kubeadm token create print join command as shown above. It is advised you to not to use this frequently as it will create new tokens every time you run it. So now we have Kubernetes master and the worker nodes and all components are configured and ready. And now it's time to make sure everything is working correctly, and for that we'll test with deploying a sample application in the next slide. Currently we are on the master node. So to display the nodes inside the cluster, we'll use the kubectl get node command. As you can see from the output, we have 4 nodes. One is master and 3 are worker nodes, and all are in ready state, which is what we are expecting. Overall, cluster looks healthy and working perfectly. Now let's deploy a sample application and check if there are any issues with it. So to create a deployment, we'll execute the kubectl run command followed by sample application. From the command output, it is confirmed that deployment has been created successfully. Now, to display the pods which are created as part of this deployment, we will run the kubectl get command. As you can see, there is one pod which is created and running successfully as part of this deployment. From based on above testing, cluster is running with 3 worker nodes and we are able to deploy sample application successfully. So far in this video, we have discussed about what is kubeadm and what are some of the commands related to kubeadm and what are the 6 steps that are involved as a part of configuring Kubernetes cluster using kubeadm. So before we end this video, let's review some of the important points that we discussed in last few minutes as part of the summary. So coming to the summary, in this video we first discussed what is kubeadm and what it does. So kubeadm is a command line utility which helps us with installing and configuring Kubernetes cluster. Then we discussed about kubeadm commands such as kubeadm init to initialize the Kubernetes cluster, kubeadm join to join the worker node to the cluster, and more. After that, we discussed about the 6 steps involved in creating Kubernetes cluster. They are: first, we need to create the VMs. In our case, we have created 4 CentOS VMs, where 1 is master and 3 are the worker nodes. So once the VMs are up and running, then we disable SELinux and swap on all nodes. After that is done, we install the Docker, kubelet, kubeadm and kubectl on all nodes and make sure Docker and kubelet is enabled and started on all nodes. Then we initialize the master node with kubeadm init command. After that, we configured pod network add-on on master node. So we use Flannel in our setup. Finally, we have joined worker-nodes to the cluster by using kubeadm join command. So those are the 6 steps that are involved as a part of configuring Kubernetes cluster using kubeadm. And we also did some testing to make sure our setup is correct. And it did work as it should be. So that's about configuring Kubernetes cluster using kubeadm. And now coming up, the actual demo, where we will perform exact steps to configure Kubernetes using kubeadm. And thank you so much for watching this, and I hope to see you in the next video.